So here we are considering the nitrogen dioxide dinitrogen tetroxide equilibrium again, with an initial concentration of the dinitrogen tetroxide of 0.1 moles per liter, and nitrogen dioxide has an initial concentration of 0 moles per liter. And at equilibrium, we're told that the concentration of N2O4 was measured to be 0.009 moles per liter, and we're asked to calculate KEQ. What's interesting about this solution is that this equilibrium does not proceed to the right as we are used to seeing them do. We're used to watching them proceed from the reactants to the products, but that's not what happens in this case. We have an initial concentration of the dinitrogen tetroxide, but we don't have any nitrogen dioxide initially. So that means that this reaction is going to have to proceed back to the left, and that's why in the second row of my icebox table I've subtracted X and from the dinitrogen tetroxide, and I've added 2X because of the coefficient in front of the nitrogen dioxide, and then have used that information to be able to write expressions for the equilibrium concentration of nitrogen dioxide. Once I've got that, I can solve for X, and then use X to solve for KEQ using the equilibrium concentrations. So those are the equilibrium concentrations. And finally substituting back into the equilibrium constant expression and reporting my answer to 3 significant figures in this case. KEQ I have found to be equal to 0.272.